So sorry, we were discussing the associative law. So now associative law for the multiplication will be like this. So we took three complex number, and then you can multiply first z2 and z3, then multiply it with the z1, and in another way you can multiply first z1 and z2, and then you multiply it with z3. You will get the same result. Then you will say that multiplication of these three complex number is following the associative law. Number four is what is the multiplicative identity. So you have one complex number z, let's say, and if you multiply the inverse of this complex number with it, if you are getting the one, then this quantity is called the multiplicative uh, inverse of this complex number z. Okay, how to calculate it I will let you know, or we can discuss it here. So initially we were writing that complex number is denoted by a plus iota b. Then to calculate the z inverse, which will be equals to 1 by z, simply we can write it like 1 upon a plus iota b. But now we want to represent this number in the form of x plus iota b iota y. So this is real part and this is imaginary part. So what we do here, we multiply this number with its complex conjugate. I will let you know what is the complex conjugate in the next 5 minutes. So after multiply it, you will get in the numerator a minus iota b, and in denominator you will get the modulus of this number. So that will be simply a square plus b square. Okay, so this is the multiplicative inverse of the z. So these were the some property which we were discussing in the last class. Now today I will let you know that how to represent a complex number in a plane, and what is the polar representation of the complex number. So complex number in a plane, complex number in a plane, and after that we will discuss the polar representation. So let's take the Cartesian coordinate system. In Cartesian coordinate system we have x-axis and y-axis which are perpendicular to each other. Perpendicular means they are at the 90-degree. In the left hand side it goes in the negative x direction, in the bottom it goes in the y. Now let's take a point in this plane or xy plane. So this is point which is denoted by the x and y. So what does it tells that x coordinate on the x axis, which is like this way. So this distance from the y axis is the x distance. Now similarly this y is the y distance from the x axis, and now if you connect these 2 points, which is the point P, which coordinate are the x and y. Now, if you connect, this is the origin. If you connect these 2 points, and which we are denoting right now it by r, okay. And let's say this point P. So simply you can calculate the distance between 2 points, that is OP, which is simply y minus 0 ka square, then plus x minus 0 ka square, the square root, which you have done in class 9th, how to calculate the distance between 2 points, which is simply y square plus x square, which is we are denoting here small r. Now in this plane, this p point is the representing the complex number if x is the real part and y is the imaginary part. So you can say that this y axis is the imaginary axis and this is real axis. Then you can say that point P is representing a complex number which we are denoting by z, that is simply x plus iota y. Now, if you want to take the mirror image of the point P in the x-axis, so this point will be simply like here. So you can see that you are just changing the y coordinate of the point, because on the x-axis you are not going anywhere, you are exactly at this point. So you are, this point will be similarly x, but on the y-axis, or you can say on the imaginary axis, this y point is now in the negative x direction, sorry, negative y direction, which is now minus y. So mirror image of point P in the x-axis will be q. Now simply mirror image of point P in the y-axis, similarly we can calculate. So in this direction, this will be the point, Now you are just fixed at the y coordinate, but you are changing the x coordinate because you are traveling on the x axis. So now in you are in the negative x direction, so this point will be minus x and the y will be similarly you can take the mirror image of this point in the x axis, negative x axis. So it will be like this point, and now again you have fixed the x coordinate which is minus x, but you are traveling in the minus y direction, so this is minus y. And now the mirror image of this point will be to this one. Now we have represented here four complex number in four different quadrant, and which you can say in the first quadrant the complex number is simply x plus iota y, which is denoted by this one. The second quadrant, so I am denoting 1, and then second quadrant it is written by minus x plus iota y. In the third quadrant, which I am writing here z3, which is simply minus x minus iota y, and in the fourth quadrant is z4, which is simply x minus iota y. So this is the representation of the complex number on a plane. Now if the question is writing this way, so z is equals to 1 minus iota root 3. So can you tell me in which quadrant this complex number lies? So simply we will draw the complex plane, which is simply x and y. Now you can say that the real part of the complex number is 1, and the imaginary part of the complex number, which is with iota, which is minus square root of 3. So 1 and then minus square root of 3. So 1 is on the x-axis, that is real number, let's say 1, 2, 3. So this 1 point is here, and then minus root 3, so it's going in the negative y direction. So somewhere this is 1 and this is 2, so between this somewhere here. And if you connect these 2 points, then this is your point in the complex plane, and if you connect this, then you can calculate the distance of this point from the origin, which is the r, which is also modulus of the complex number z, which is simply distance from the origin of the point p. Okay, now if you want to calculate this, then it will simply be the real part is square plus imaginary part is square, which is simply 1 square plus of minus root 3 square is equals to 1 plus 3, simply gives you square root of 4, that is 2. So this point is 2 unit distance away from the point origin O. So okay, now similarly another number, let's say you have 2 plus root 3 iota. Simply by just looking on this, you can say this point is on the first quadrant, because the both real and complex part are the positive, so it will be in the first quadrant. Then you can calculate the modulus of z for this number, and similarly to r. Now the next is the polar representation. Okay, polar representation of a complex number. This is very simple, like the as we denoted a complex number in a plane. So what we did, we took a point and we connect it with the origin, which was O, and we said that this is r, and this point is x and y. Now we were writing that z is equals to x plus iota y. You can take anywhere this point in the any quadrant, but right now for simplicity we are taking in the first quadrant. Now this is the complex number, okay, and which is written as x plus iota y. Now the point is that I told you that this distance is x from here to here, and this distance is y, or similarly you can say either this way. So because both are the same thing. Now if this distance r, or this distance making angle theta with x axis, now you have this right angle triangle, because x and y are the perpendicular to each other, and now this is right angle triangle, this is the y distance, and this is x distance, and angle theta is here. Now in this triangle, now polar representation means you have to denote the complex number in terms of this theta and r. So polar representation, just like in the Cartesian coordinate system, we represent everything in x and y coordinate. In polar representation, we represent everything in the term of the r and theta. So r is the radial distance and theta is the polar angle for the any point in the polar plane. Now, if we want to take here cos theta in right angle triangle, which is trigonometry simply from the 9th and 10th class, which you have done already. So let's say this is OAB triangle. Now cos theta is simply base divided by perpendicular, which gives you x divided by So this is R, and so this is the hypotenuse OB, which is R. So now you have got the x equals to R cos theta. Simply, if you calculate the sine theta, which is simply y divided by R, then it will give you y equals to R sine theta. You can make the sine theta and cos theta in the angle. Now you got the value of x is equals to R cos theta, and simply value of the y is R sine theta. By replacing x and y in this, we will get that z is equals to simply x was equals to R cos theta, that is R cos theta plus iota, and y is R sine theta. R is the common in the both numbers, so R you can take outside the bracket, and this is cos theta plus iota sine theta. So this is the polar representation of a complex number, and if you want to take the modulus of this complex number, that will give you simply modulus of R, and then inside the bracket you have this cos square theta plus sine square theta, which is again 1. So modulus of z is equals to mod of R, the distance from the origin of the point. Second, you can also write this R, and the second part is e power iota theta. Simply this can be written as cos theta plus iota sine theta. So basically, in the polar representation of the complex number is simply e power iota theta. And if you take the modulus of this one, then we'll give you mod of R. So this is the polar and plane representation of a complex number. We will solve one example. Now this theta, first we can discuss that this angle theta, we represented point here by this distance r at the point P from origin O. It is an angle making angle theta. Now this P can go or make a complete circle in this plane, and the theta will start from 0 to it will go 2 pi. Okay, so value of theta can go from 2 pi to 0. One thing like this way, another this, instead of taking this complete circle, you can take two semicircle. So this goes from here, which is from 0 to pi. So theta can go 0 to pi, and then again going completely in this direction, you can go in this direction. So it will be again the from minus pi to pi. So in this direction, it will be minus pi to theta to pi. So this is again value of angle theta. So if you go in this direction, then you will take the minus direction, and if you go in this direction, then the positive direction. So this is the polar representation of a complex number. By taking one simplest example, we will see that how we can represent a complex number in the polar form. So this is the simplest example, 1 minus iota root 3, which we took earlier. Now how to represent in complex numbers. So we know that the complex representation of a complex number is this one. So it also can be written as r cos theta plus iota sine theta, which is simply is equals to x plus iota y, and then x was equals to r cos theta and y was equals to r sine theta. By comparing these two terms in this complex number, you can say z was simply equals to x plus iota y. Now x we got here 1, and y we got equals to minus root 3. Now we can put this value is equals to this polar form, which is equals to r cos theta, and this is r sine theta. Now if you square these two terms, or you calculate the magnitude of this x square plus y square, just 1 second, which is simply r square, which is cos square theta plus sin square theta. And if you take the magnitude and square root of this, that will give you distance r is equals to 1 plus 3 square root, that is equals to 2. Got it? Now in the polar form, we know that we have to calculate the angle theta, then we can write in term of the cos theta and sin theta. So r we have got, that is 2. Now by definition, that cos theta is equals to r cos theta. Now you know the value of x is equals to 1 and r equals to 2. The cos theta will be equals to simply 1 by 2. Simply y was equals to r sin theta. R is equals to 2, and then sin theta and this in this side you have minus root of 3. So sin theta will be equals to minus root 3 by 2. So now calculate the theta angle, that is sin inverse of root 3 by 2. Simply here theta will be cos inverse of 1 by 2. Now you see that cos is positive value and sin is negative value. So in which quadrant you are going to be? So let's, in the first quadrant both numbers should be positive, but in the second quadrant sin is positive. Let's in the third quadrant calculate. In the third quadrant, uh, still the cos is negative and sin is negative. So in the fourth quadrant we are where the cos is positive and sin is negative. So you can calculate theta here by saying that theta is simply 1 by 2 will give you for the 30 degree, for the sorry, for cos it will be 60 degree, which is simply pi by 3, but in the fourth quadrant it will be simply 2 pi minus pi by 3. So simply it will be pi by pi 5 pi by 3, and for the same angle you will get the sign in negative. So final representation of the complex number, it will be 2 into cos 5 by upon 3 plus iota sine 5 pi by 3. So this is the polar representation of a complex number. For today I think this is the sufficient, and then we will discuss rest of chapter in the next video. Thank you so much.